Sketch or Hook, a collaborative video hook approach to advancing scientific engagement. The project that began in 2012, and it was really about the development of a set of lesson hooks for the Junior Cert Science classroom. And we used video technology in order to develop these lesson hooks. So the research grew from the fact that despite an abundant number of resources that were available, that student teachers still found it very difficult to design curricular relevant hooks to engage students when they were out on teaching practice in the schools. The research on the development of lesson hooks is very minimal in the literature. Also, in terms of effective methods of science teaching pedagogy, the research indicates that interactive student-centered pedagogy can play a pivotal role in maintaining student interest and student engagement. Also in 2012 and even currently in our Irish schools, there has been a rapid influx of mobile technologies. Currently about 20% of Irish schools are iPad schools. And for that reason, we thought this was an apt opportunity to maybe use mobile technologies to create resources for the science classroom. So our aim as teacher educators was to work with student teachers in order to have a collaborative process in developing hook e-resources for the science classroom. The student teachers soon became student researchers because we designed a research thread throughout the project. The initial part of the project was a 10-week summer project during 2012. And then the student science teachers also became student designers of the resources. Our final output was 3 hook books, which were iBooks that are freely available on the iBook store. And each hook book has about 13 short concept videos in each one. So a brief overview, we had 2 teacher educators, I was one, and a fellow colleague, Sean O'Grady, was another. His area is in technology education and geography education. 7 student science teachers. We had 3 design teams, one in physics, one in chemistry, and one in biology. Martin was based in the physics design team. We didn't begin the research until after the students' assessment had been completed for ethical reasons. We organised 6 focus groups throughout the project, and we had the teacher educators and the student teachers also keep a series of research journals. So what are science hooks? Well, a hook represents an instructional method used at the beginning of class to grab attention, to foster interest, and to create engagement. So it's pretty ambitious, but that's what we were trying to set out to do. It can be as simple as a photo, an image, a short story, a video clip, a demonstration, and so on. Essentially, we were hoping to get the students and the teachers on the edge of their seat. So the research around engagement, so just to bring you back again, the 3 core concepts we were looking at were attention, interest, and engagement. So in terms of engagement, it refers to how connected and interested pupils are in their classes. Students are more likely to pay attention to and learn about and remember events that provoke emotional responses or that are related to their interests. So what we did was we just focused more so on the interest literature in terms of a theoretical background to our research. The model that we looked to is Heidi and Renninger's 4-phase model of interest development, which talks about situational interest and personal interest, and it gives strategies about how to move a student from situational interest towards personal interest. Situational interest, which is more short-lived, it's sort of an external trigger just to excite students in the moment, almost like an explosive demonstration in the science classroom, where the ultimate aim would be to move the students more towards sort of a sustained personal interest, where eventually these students might take science as a subject that they want to further into their careers. Okay, so I'll move you over to...
So basically, when we were charged with the task of making the physics hooks, we basically looked online to find the various different aspects that you could use in your own teaching to get students interested, and then we had to pick the ones that would work in a visual medium, ones that you could place or transplant into a video. So we found three things, things that are relevant and recognizable. I'm sure teachers will agree with a lot of these things. The second one was challenges and puzzles, or questioning. And the third one was anomalies, things that don't intuitively make sense. So what I'm going to do is present the three different aspects in three different ways, and then show you how we built those various aspects into the videos. So the first one we have here is the relevance, and the first question is, how do you make a room full of teachers and researchers look at their own thumbs? And that's my answer to that question. Basically, this is a picture of two types of thumbs, a hitchhiker's thumb and a regular thumb. And I see some people checking their thumbs already. Generally, when I'm teaching a classroom, I challenge the students not to look at their own thumbs. And anyone who teaches first or second year class will realize it will be nearly impossible for them not to look at their own thumbs when they see this. This is the recessive trait, the hitchhiker's one, and the regular one is the dominant trait. Does anyone have a hitchhiker's thumb in the room? Yeah, the exits are there and there. You can. I'm only joking. You're fine. So this is basically your relevance strategy because everyone can relate to it, and you can see how it acts as a hook for some people, and it did for some people in the room. The second one here is our challenge or our question. So this is a matchstick demo, and we're going to be setting this up in a minute. But basically, the question is, we have the. I'll just press A again. It should pop up. Okay. Basically, we're going to set up the matches like they are set out in this picture. And we have A and B here. Note the match in the middle. A is the wooden end in the middle match, and B is the matchstick end. So you have two matchstick ends here and just one here. The question is, if I set the middle match on fire, which end will burn first? Is it A, the wooden end, B, the match head end, or C, other? And I'm calling you skeptics. Basically, whilst we're setting this up, we're going to give you a minute to come up with an answer yourself, to talk to your neighbor. If you do say C, other, come up with some, don't just say C, I want you to come up with an explanation and give us the explanation for it. So we're just going to set this up and you can talk to each other and figure it out. Okay, so you can see how, I mean, when you're doing that with a second year group again, they're not going to come up with the answers straight away. They're going to have arguments about whether it's A or B, and you can see how that can act as a relevant hook within the classroom. Okay, so your last thing I'm going to talk about is something to do with anomalies. Now, this is the Monty Hall problem, and I'm going to run through this. Some people have in this room, I know because I've taught it to them, have heard of the Monty Hall problem before. Hopefully some of you haven't, but it's basically the type of thing that when you show it to someone and you explain it to them, it doesn't intuitively make sense, and they'll sort of disagree with you. And what you'll find is it sort of draws interest. So basically, the Monty Hall show was basically a show that was on in America in the 80s, and they used to have this at the end when you won. You got the choice between three doors. Behind two of the doors are goats. Don't ask me why they're goats, they just are. And behind one of the doors is a shiny new car. So obviously you want the shiny new car and not the goats. So if you pick one of those doors, what are your odds of winning? 1 in 3. So 33.3 continual % chance of winning. So that's it. So we'll just run through the game quickly and we'll play the game. And let's say, hypothetically, we're picking door number 2. Now, if you pick door number 2 and there's a car behind it, what is behind 1 and 3? Goats. If you pick door number 2 and there's a goat behind it, what's between door number 1 and 3? A goat and a car. So you would all agree that there has to be at least a goat behind 1 and 3. Yes, okay. So what happens is when you pick door number 2, the host then goes to one of the doors with the remaining goats and reveals to you, behind door number 1, he reveals the goat. And then you were asked the famous question, would you like to stick or would you like to switch? And it's to the audience, what do you do? Stick. Switch?
Switch.
Well, you can see, just going back to the sort of pedagogy behind it, there are a lot of people here, you know, with opinions, you stick, you switch, and everything else. And everyone, when they first see this, basically, what do you think the odds are between picking door number 2 and 3? 1 and 2 all the time, 50%, yeah. Basically, believe it or not, you actually have a 66% chance of winning if you pick door number 3, and you have a 33% chance of winning if you stick. And you've suddenly gone quiet. So that will basically say that, you know, it's the anomaly. You're basically saying, Martin, you've gone off the head. You don't make any sense. The best way to kind of make some level of sense of it is if I go back to here when I was telling you what is behind the doors. If I offered you a choice between only door number 2 or door 1 and 3, which would you pick?
1 and 3.
You would pick 1 and 3 because you have the 66% chance. okay? However, if you pick doors 1 and 3, there would have to be a goat behind one of those doors, correct? All the host is doing is showing you the goat. And it's due to a process called variable change, and it's really hard to explain, and I'm not going to try to explain it here because we'll be short on time. But believe it or not, it is 66 and 33. And what I have included is a process tree, so anyone who doesn't believe me, which I'm sure a lot of you don't, you can basically go through this process tree afterwards and you can figure it out and work it all out. So the question is then, how do you combine those 3 elements into an effective video that can act as a hook in the classroom? So basically, I'm going to play the video and then talk to you through the elements and how we built them into the video.
How do you find the center of gravity between a spoon, a fork, and a toothpick? Now let's see if we can find the center of gravity between a hammer, a ruler, and a piece of twine. Do you think this experiment would still work with a meter stick and a sledgehammer?
Okay, so that's basically your video. If you look at that video and you break down the various aspects inside it, the relevance strategy comes from the fact that we're using everyday household objects where possible. So the students should be able to recognize most of those objects within the video, and that'll make it more relatable to them. The challenge comes from the fact that throughout the video, they're constantly being asked questions. Do you think you can find the center of gravity of A, B, and C? And the video is set up in a sort of slow way so they can form a mental image of what's going on and think about what's going on within the video. The last thing is the anomaly aspect. So we essentially tried to do demonstrations that wouldn't intuitively make sense. So most of you would say that when you look at the sledgehammer hanging off the ruler, it doesn't look like it should hang that way, it should fit that way. So that's the anomaly aspect. So that's basically the 3 major elements that we tried to build into the majority of the video so they would act as hooks for the students in the classroom. So I'll now hand you back to Veronica to round off the presentation.
Okay, so short summary again is we developed 3 iBooks, one in physics, one in chemistry and biology at junior cert level. There are 12 chapters within them. Also the reason why we chose to develop iBooks is because in 2012 iBook author software became freely available to use. Apple allowed the public to use it freely, for free. And therefore we used an iPad platform. So our findings from our preliminary findings are that the collaborative engagement allowed both of the student teachers and also the teacher educators to develop an advanced skill and knowledge set. As you can imagine, we set up a lot of experiments and we all learned actively from the process. In terms of the hook design method, we were able to sort of put together a very simple 3-step method in terms of how we designed each hook. So first of all, to identify the topic, review resources that were available currently online and in books, and also to connect with the curriculum. Then to develop pedagogical strategies. The students worked in pairs, doing research online in the lab, outside in the grounds of the university. And they considered a number of pedagogy questions that would be able to be infused within each hook. And then finally, evaluate and create. They developed storyboards, they self-critiqued them, and then the design team also critiqued. We brought in film and animation experts to record the movie clips, and then the final peer group reviewed at the end. We came up with what we felt would be the 5 effective elements of a hook, and they are to grab student attention at the beginning of class, to ground the hook in a relevant everyday life, to foster questioning throughout the hook. They had to be connected to the curriculum, and also that the hook would give a snapshot of the lesson that was to follow. And finally, we sort of noted the pedagogical value that we felt that these hooks could have to teachers in the classroom. First of all, we were very aware that science teachers have very little time. We also felt that it could strengthen the knowledge and confidence of teachers in science, especially out-of-field teachers. We folded in elements of numeracy and literacy, which is, it's dominant at the moment in science teacher education. We also tried to advance the effective use of mobile technology in the classroom. As I said earlier, over 20% of schools in Ireland are iPad schools, but whether or not they use them effectively is a question that we're grappling with at the moment. Also, they could be used as an instructional video. So some of the videos were video demos, so a teacher could look at the demo before class and actually trial out the demo themselves rather than play the video. And we also hoped through the questioning that we used and further explanation that they could be used to clarify some common misconceptions in science. So where we stand at the moment is that Martin's PhD is in this area, and he is trialling these video hooks in classrooms with teachers. A few of them are here today throughout Ireland, and as the research develops, we hope to share that with you, and we can in the near future, hopefully. So that's it. Thank you very much.